Welcome to the DIY Honda Garage channel. DTC P0112 refers to a low voltage condition detected within the intake air temperature IAT sensor circuit, particularly relevant for the Honda Fit models from 2015 to 2020. The IAT sensor plays a crucial role in measuring the temperature of the air entering the engine. This measurement is vital for the engine control module, ECM, allowing it to adjust fuel injection and ignition timing for optimal engine performance. A low voltage reading from the sensor can lead to inefficient fuel usage or engine performance issues. When diagnosing this DTC, it's important to ensure the system is functioning under normal conditions. This requires detailed steps that involve verifying signals, checking for outside influences, and inspecting critical components related to the IAT sensor and the mass airflow (MAF) sensor. The IAT sensor is pivotal in monitoring the temperature of the air entering the engine. Typically installed near the air intake, it informs the engine control module, ECM, about current air temperature, allowing real-time adjustments to fuel-to-air ratios. A defect in the IAT sensor or its circuit can result in inaccurate temperature readings, ultimately impacting the engine's performance and efficiency. It is closely associated with the MAF sensor as they both influence the ECM and its capacity to control combustion effectively. Proper functioning of the IAT sensor is essential for emissions control and overall vehicle performance. Hence, any DTC indicating a malfunction must be promptly addressed, focusing on each component with precision. There are several potential causes for DTC P0112. A primary issue may be low voltage detected in the IAT sensor circuit, which can be indicative of faulty wiring or connections. Poor connections or loose terminals, particularly near the MAF sensor and the IAT sensor, can lead to intermittent failures. Another significant possibility is a defective IAT sensor or MAF sensor, either of which may fail to produce the correct signals required by the ECM. Each of these causes needs to be systematically evaluated to ensure the problem is correctly identified and rectified. Understanding the interaction between electrical components in the system is vital for troubleshooting this specific DTC. The symptoms associated with DTC P0112 can manifest in several ways. One common indication is the illumination of the check engine light on the dashboard, which alerts the driver to a potential issue within the vehicle system. Drivers may also notice fluctuating engine performance, such as rough idling or sluggish acceleration, which can result from improper fuel-to-air ratios caused by erroneous temperature readings. Additionally, drivers might experience poor fuel efficiency, as the ECM may not optimize fuel delivery effectively without accurate data from the IAT sensor. Recognizing these symptoms is crucial for timely diagnostics and necessary repairs to maintain overall vehicle functionality. Beginning with the first troubleshooting step, ensure the vehicle is turned to the on mode. Utilizing the Honda Diagnostic System, HDS, check the parameters related to the IAT sensor. Specifically, you want to verify the voltage reading coming from the IAT sensor. It should be less than 0.08 volts. This step is crucial to establish whether the system currently matches this threshold. If it does, it indicates that the failure is confirmed, and you should proceed to the next step. If the readings do not match, it may suggest an intermittent failure, requiring a check for poor connections or loose terminals, especially around the MAF sensor and the powertrain control module, PCM. This meticulous check is fundamental for ensuring robust troubleshooting before advancing further. In the second troubleshooting step, After turning the vehicle off and ensuring safety protocols, disconnect the MAF sensor/IAT sensor 1 5P connector. Once disconnected, turn the vehicle to the on mode once more. Following this, utilize the HDS to check the parameters related to the IAT sensor again. It is vital to ascertain that the reading from the IAT sensor remains as it was in the first step, specifically less than 0.08 volts. Should the readings match, then it directs you to the next troubleshooting step, where further investigation is required. Conversely, if the readings indicate that the IAT sensor is functioning properly, this implies that the sensor itself may need replacement, as it may be the root cause of the diagnosed problem. For the third troubleshooting step, begin by turning the vehicle back to the off mode. This is a safety measure before proceeding. Next, you will jump the SCS line using the HDS to establish a test environment. After this, disconnect the PCM connector B, which has 51 pins, to facilitate further testing. With both the MAF sensor IAT sensor 1 5P connector and the PCM connector disconnected, it is essential to check for continuity between designated test points. The points of interest are the number 4 terminal of the MAF sensor IAT sensor 1 5P connector and a body ground. Establishing continuity here is vital, as it indicates whether there is a short circuit present in the TA wire between the MAF sensor and PCM. If continuity exists, this calls for repairs in the respective wiring. If not, the TA wire might still be fine, suggesting further action like updating or substituting the PCM may be necessary. Once all necessary repairs have been conducted, it's critical to verify that the repair was effective. Begin this verification process by confirming that all actions taken align with the troubleshooting steps outlined. Clear any stored DTCs from the PCM to ensure a fresh start for new tests. After this, it is advisable to retest the system under similar conditions to ensure that no fault codes reappear and that the vehicle performs as intended. Monitoring the vehicle's overall performance for a period afterward provides valuable insight into the efficacy of the repairs and can aid in identifying any ongoing issues. This final verification step is essential in confirming that the issue has been resolved satisfactorily. To prevent future occurrences of DTC P0112, implementing a solid preventive maintenance schedule is beneficial. Regular inspections of electrical connectors related to the IAT and MAF sensors can help catch any signs of wear or corrosion before they cause problems. This proactive approach minimizes the chances of poor connections leading to erroneous readings and subsequent DTCs. Additionally, maintaining the condition of the sensors themselves through periodic cleaning and functional checks can help ensure optimal performance. It is also advisable to stay current with any updates to the PCM software, as this can play a critical role in ensuring that the vehicle systems operate smoothly and efficiently. Well-maintained systems contribute significantly to vehicle reliability and performance. In conclusion, understanding the role of the IAT sensor and the implications of DTC P0112 is integral for effective vehicle management. Rigorous adherence to structured troubleshooting steps allows for the identification of the specific issues affecting the vehicle performance. By systematically evaluating the electrical connections, wiring, and the sensors themselves, effective repairs can be achieved. Moreover, adopting a regular maintenance routine not only signifies a proactive approach, but also plays a vital role in preventing future diagnostic trouble codes like P0112. Ensuring your vehicle is in prime condition enhances not only its performance, but also overall safety and efficiency on the road. These key points will serve any technician well in the ongoing management of Honda Fit vehicles. Please like and subscribe to the channel. See you next time.